Hello friends, my name is Abhishek Srivastava. Today we are going to do the topic the root and square roots of maths of class 8. So we are proceeding with the questions. First we are doing value of finding the value of the squares. For example, 51. 51 is square. We have to find it using the identity. So here you can write it as 50 plus 1 and it's square. So it becomes the identity of a square, a plus b whole square. So from here we can write this is 50 square plus 1 is square plus 2 into 50 into 1. So this is our equation. Now 50 square, so it is 2500 plus 1. 1 square is 1 plus 2 into 50 into 1 is 100. So adding it, it becomes 2601. So this is our square of 51 using the identities. So I think you all might have understood this question. So we are going to understand this question once more. So here 51 is square. We are trying to find out the square of 51 using the identity. So we can write 51 as 50 plus 1 and its whole square. So the value doesn't change. It becomes a plus b whole square. Identity a square plus b square plus 2ab. So we can write it as 50 square plus 1 is square plus 2 into 50 into 1. So it becomes 2500. 50 square is 2500. 1 square is 1 plus 2 into 50 into 1. So it is 100. So adding it, it becomes 2601. 2601. So this is our square of 51. So now we are proceeding to the next question. So the next question is finding the square of 101. 101 is square. We have to find the value of this square of 101 without using the identities, without actually multiplying it. So now we are proceeding to the question. So it is, we can write it as 100 plus 1 and its whole square. So it becomes 100 square plus 1 square plus 2 into 100 into 1. So this is our equation. It is a square plus b square plus 2ab. Expansion of a plus b whole square. So it becomes 100 square is 100 0 0 0 0 plus 1 square is 1 plus 2 into 100 into 1, that is 200. So adding it, it becomes 10201. This is our answer. So I think you all might have understood this question. So we are going to understand this question once more. 101 square. So it is, we can write it as 100 plus 1 and its whole square. So it becomes 100 square plus 1 square plus 2 into 100 into 1. So it becomes 10000 plus 1 plus 200. So it becomes 10201. So this is our answer. So I think you all might have understood this question. So we are proceeding to the next question. So the next question is 99 square. We have to find the value of 99 square without actually multiplying it using the identities. So we can write 99 as 100 minus 1 and its whole square. So it becomes the identity of a minus b whole square, which is expanded to a square plus b square minus 2ab. So we can write it as 100 square plus 1 square minus 2 into 100 into 1. So I think this much you all might have understood. So now we can write 100 square as 100 plus 1, 2 into 100 into 1, that is 200 minus 200. So it becomes 9801. This is our value. This is the square of 99 square. So I think you all might have understood this question. So we are going to understand this question once more. 99 square, that is 100 minus 1 square. So it is 100 square plus 1 square minus 2 into 100 into 1. So it is 10000 plus 1 minus 200. So it is 9801. So I think you all might have understood this question. So we are proceeding to the next question. So now we have to find the square root of 625. The square root of 625 using the long division method. So here we will write it like this: 625. We will make pairs and we will proceed from the left side to the right side, making pair of 2. And if a single digit is left, then that will be the single group of 1 digit at the end. So here a group of 2, then here a single digit remains, so it becomes a group of single digit. So now 6 is there, so we are going to read the table in squares. 1 1 ja 1, it is 2 2 ja 4, just next lesser number. 3 3 ja 9, so 2 is the next lesser number, so it will go by 2. 2 2 ja 4, so it is coming out to be 4 minus subtraction is there similarly as division. So here 6 minus 4 is 2, and 2 numbers are copied in a single time at once, so it is 25 is copied. Here we have it has gone by 2 times, so same number we add, so 2 is added to it, so it becomes 4. Again we are going to read it in the square form. So in the end it is 5, so it might go by 5. So 5 into 5, so it is 45 into 5. So 5 5 are 25 to carry, 5 4s are 20 plus 2 22. So it becomes 225. So it goes by 5 times. So it is coming out to be 225. So it is exactly divisible. So it is a perfect square. So 25 is the perfect square root of 625. So 25 is our answer. So I think you all might have understood this question. So we are going to understand this question once more. 625. We have to find its square root. So here for finding the square root, we make pairs of 2 digits from the left and move towards the right. So we are moving from the left side. So in the left side it is 25. It becomes a pair of 2. Then 6 remains, which is a single digit. So single digit becomes, if it is left single, then it will be again a group of single. So 6 is another group. So now we have to divide 6, and we divide it in the form of squares. So it is goes by 2 times 2 2s are 4, because 4 is the just lesser number than 6 in terms of squares. So it is coming out to be 4. 6 minus 4 is 2. Two numbers are copied at one time, so 25 is copied, so it becomes 225. Here 2, it goes by 2, so a number is added to it, so it becomes 2 plus 2, that is 4. And here it goes 5 times, and exactly 225 comes, so the remainder is 0. So this is a perfect square. So, and the answer is 25. So square root of 625 is 25. So this is our long division method to find the square root of the numbers. So now we are doing the prime factorization method using the prime numbers starting from the lowest, that is 2, and moving towards the bigger prime numbers to divide and finding the square root. So we are going to find the square root of the same number 625 by prime factorization method. So we are proceeding to the question. So I think you all might have understood this much. So this is 625 using the prime factorization method. In the end it has 5, so it is divisible by 5. So it comes out to be 125. Again it has 5 in the end, so it is again divisible by 5. So again it is divisible and it comes out to be 25. Again it has 5 in the end, so it is again divisible by 5. So it is 5 5s are 25. Now again it is 5, so it is divisible by 5. 5 and 5. So each time it is divisible by 5, and it has 4 5s. So we can make a pair of 2, so 2 5s and 2 5s. So we take 1 5 from each pair, so it is 5 into 5, so it is 25. So 25 is the square root of 625. This is our answer. So I think you all might have understood this finding the square root by prime factorization method. So I think we are going to understand it once more. 625, and we are dividing it and finding it by the prime numbers. So it is not going by 2, 2 is the smallest prime number, then 3 is not going by 3 as well. So we are coming to the bigger prime number, that is 5. Divisibility test of 5 also says that if the last unit digit is 5 or 0, it is divisible by 5. So here it is divisible by 5, so it is coming out to be 125. So again 125 is again divisible by 5, so again dividing by 5, so it is coming out to be 25. Again 5 in the end, unit digit is 5, so it is again divisible by 5, so it is 5 ones are 5 5s are 25. Again 5, so 5 is divisible by 5, 5 ones are 5. So there are 4 5s and making a pair of 2, so 2 5s, it becomes taking 1 5 from each, so it is 5 into 5, that is coming out to be 25. So 25 is our answer. So the square root of 625 is 25. So I think you all might have understood this question. So there is another way to find the square root of a number. Suppose 25. We are finding the square root of 25. What will be the square root of 25 without actually dividing it by prime factorization and long division by the method of odd numbers. So here it is 25. So subtracting the odd numbers from the lowest to the biggest odd number, subtracting 1. 1 is the lowest odd number, so it is coming out to be 24. Subtracting 3, the next odd number, so it is coming out to be 21. Now subtracting 5, the next odd number. So it is coming out to be 16. Again subtracting the next odd number, that is 7. So it is coming out to be 9. Subtracting the next odd number, that is 9. So it is coming out to be 0. So you can see there are 5 times. This is 1, 2, 3, 4 and 5. 5 times it is subtracted by 5 odd numbers, from starting from the lowest till the highest, that is 1, 3, 5, 7, 9. So the number of times odd numbers used is 5. So here what we do is we square this number. So taking the square of 5, that is 25. So this is, so the square root of 25 is 5. This way we find it without actually using the prime factorization or dividing it or the long division method. So this is also one way, by expressing the square root in the form of the sum of the squares. So I think you all might have understood this question. So we can understand it once more. This is 25. So 25 subtracted by the lowest odd number. We start with the lowest odd number and we are going on increasing the odd numbers. So here 25 minus 1, that is coming out to be 24. The next odd number is 3. Subtracting it by 3, so it is coming out to be 21. So the next odd number is 5. Subtracting by 5, so it is coming out to be 16. Subtracting by 7, which is the next bigger odd number, so it is coming out to be 9. The next bigger number is also 9. So 9 minus 9, that is 0. So 5 odd numbers are used to reach to this 0. So this 5 is the square root of this 25. If we square 5, it comes out to be 25. So the square root of 25 is 5. Expressing it in the sum of the first 5 odd numbers, that is 1, 3, 5, 7, 9. So I think you all might have understood this question. So please watch this video till the end, subscribe me and press the bell icon. Thank you.